Calculus, video 56, linear approximation, example 1. So let's use linear approximation to approximate the square root of 4.36, then find the error and the relative error. Okay, first of all, before we start the approximation, let's get a picture of what's happening. We're trying to approximate the square root of 4.36. Therefore, the function we're looking at is f of x equals square root of x. Right, so we're saying what is the function value at 4.36? F of x equals square root of x looks something like this. And we are trying to approximate the function value at 4.36. So what is this y value there? What is the function value at 4.36? What we're going to need to do is to find an a value somewhere close to 4.36 that we know the square root of. Right, that should be our first thing. What would we like to let a equal? Let's have let a equal 4. Now, if you're doing calculus problems, you may be finding this a on your own, or it may be given to you in the problem. Okay, we're going to let a equal 4. So if a is 4, what we're saying here is we're going to find or know the function value at 4. We're going to find the tangent line at that point, and we're going to use that tangent line, evaluating the tangent line at 4.36, this dot in orange there, to estimate the value of the square root of 4.36. That's the idea. Let's go ahead and get our linear approximation. L of x is equal to, if you remember, f of a plus f prime of a times x minus a. That will always be our linear approximation formula. So if we let a equals 4, we're going to need to know a, that's 4, f of a, whatever the square root of 4 is, 2, and then f prime of a. So let's just write all those things down. A is 4, f of a is f of 4, that is the square root of 4, that is 2. If f of x is the square root of x, let's rewrite that as x to the 1/2 power. Then f prime of x is 1/2 x to the negative 1/2, or 1 over 2 square root of x. And evaluating that at 4, f prime of 4, the slope of the tangent line at 4, is equal to 1 over 2 times the square root of 4. That's 1 over 2 times 2. That is 1/4. Okay, from that information, we can find the linear approximation, the equation of the tangent line. We see that f of a is 2. F prime of a, that's the slope, is 1/4 times x minus a here being 4. And we get L of x is equal to 2 plus 1/4 x minus 1. 1/4 times x and 1/4 times negative 4. I can combine the 2 and negative 1 to have my line, the equation of my line, equaling 1/4 x plus 1. That is what I will use for my linear approximation. Let's see, if I take a look at that in the picture that I've drawn, does this green line look like L of x has a slope of 1/4 and a y-intercept of 1? Yeah, I think I'd buy that. We're going to use that equation of the line to approximate this point here, this f of x, the square root of 4.36. We're going to plug in 4.36 into my linear equation. That will give us the value of the orange dot there, the y value of the orange dot, L of 4.36. Okay, so L of 4.36, using the line to approximate the curve at 4.36, is 1/4 times 4.36 plus 1. That is equal to 4.36 divided by 4, 4 divided by 4, 1, 36 divided by 4, 9. 1.09 plus 1, or 2.09. This is the linear approximation of the square root of 4.36. Good. Let's now find the error. So in order to find the error, we need the actual. Remember, error is the estimated minus the actual. The estimated value of square root of 4.36 is the 2.09 that we found with a line. We need to find the actual, so all of a sudden we have our calculators now, and we're looking for the square root of 4.36, which is approximately equal to 2.0881, a little bit of rounding there, 2.0881. So that is the actual. Therefore, the error is equal to 2.09, the estimated, minus the actual, 2.0881, for an error of 0.0019. And that is our error. That's, again, just like last video, we had the line was L of x equals x, approximating the sine of x. As long as that function was around 0, that line was a good approximation. We see here as well, in this square root of x, the line L of x equals 1/4 x plus 1 is a really good approximation for the square root of x, as long as those values of x don't get too far away from 4. Right? As long as the values of x don't get too far away from 4, the line is a pretty good approximation for the function value. Let's find now the relative error, which was our error divided by actual times 100%. We like to think of relative error in terms of a percent. So error was 0.0019, actual 2.0881 times 100% is equal to 0.09%. Less than 1% error in this case.